Okay, so we have a situation here. We're being asked to draw a speed time graph, not a velocity, a speed time graph. And the story goes we have somebody running along a straight road. They start at rest, so the initial velocity 0. And they are moving with constant acceleration, so they're speeding up for 5 seconds until they get to a speed of 8 meters per second. I can get that on a graph. You can get that on a graph. You got that on a graph. You have it right. 8 diagonal from 0 up to 8. And we can mark that off. Then the speed is maintained, and it's maintained for t seconds. And I forgot something, didn't I? Let me go back. That acceleration was for 5 seconds, wasn't it? So we're going to label the 5 seconds below there. We went from 0 to 8 in 5 seconds. Next. The speed is maintained for t seconds. No change. It's a horizontal line because there's no acceleration or deceleration. And that is for t seconds. I can mark it off for clarity. And then we're looking at the fact that it decelerates for a constant rate until the runner stops. It's going down, and that takes place. They stop after 75 seconds. I put it in red. You know why I put it in red? Do you remember? From the work we did before? Yeah. It's going to be useful at some point, but not for the graph. We don't need the distance, but it's useful information, so we've noted it. We need to put in it's decelerating, so we have the diagonal going down onto 75. Now, note, I did something a bit different here because, well, we've actually marked off an actual point on the timeline 75. I thought that was useful to do based on how they worded the question. What it does mean is that if I look at labeling this section here, then I would have 75, take away, because 75 is the whole thing, isn't it? So I need to take away the t, I need to take away the 5 to get what this actual time would be here. And that looks a bit cumbersome. 70 take away t, but I put it in. It might be useful as we go on to calculate the value of t. It might be not. Probably not. But I put it in. How do the marks go for this? Actually, for the first two line segments, you're getting a mark for that. So you 0 to 8 in 5 seconds, staying at 8 for t seconds. That's what you get a mark for. Then you get a mark for the third segment going from 8 down to 75. No, it's the line segment, so actually having a diagonal going downward is what's giving you the mark. And then finally, showcasing the 8 and the 75, that's where the third mark comes from. So in this particular question, actually, what I did down here wasn't necessary to get the full marks. It might be useful to me or to you to answer the question, it might be, but in terms of the mark scheme, it wasn't necessary. All they were interested in was seeing the 8, the 75 going up, staying flat, coming back down to 75. That's all they were interested in, okay? Didn't have to show anything else to get the 3 marks. Moving on to the second part of the question. The 500 meters is important now. Yes, we need to know the distance, and we also need to know that the area under the graph is the displacement. And we can pull that one off for this easy because we're starting from 0 and we have a nice, lovely trapezium. So we just need to find the area. We need to use the area of the trapezium to find t. The area of the trapezium is 500 in this particular case. Okay, we've been told that. And the formula for the area of a trapezium is half a plus b equals h. And I've just shown it there where the a we're talking about can be t and 75. It's the 2 parallel lines in the trapezium, so the t and the 75. If we plug those values in, substitution, that's what you get. And as you simplify it, that's just saying that 4t plus 300 is 500, which means that t is equal to 50. That's the value of t. Marks are being awarded for you're working out using your method, so using the area of a trapezium or similar equivalent method, using it accurately, 2 marks for accuracy here. And then so that's 3 marks for your for actually getting to the point where you have an equation to solving it successfully to get 50. That is and using a clear method to solve to get that 50, that gives you an additional 2 marks. So that's where the 5 marks, where they're coming from. And yeah, I mean, one thing I would say, because I know the marking of these things, everybody approaches some of these questions slightly differently. If you're finding it difficult to decide how many marks you'll get, let's say you didn't do everything perfectly, you didn't show all your working, so it's not obvious you're going to get full 5 marks. If you're not sure how to award marks based on what you've done, just send a copy of your work over, and you'll get some feedback on that, okay? But once you've shown all your steps and got the correct answer, then, well, you got the 5 marks. That's the easiest bit, isn't it? When you get all the marks, when you get everything right. But yeah, any issues, any concerns with marking, just pop over your work and I'll look at it and give you some feedback on how to approach the marking. Okay? Bye-bye for now.